All right, this is kind of exciting. I feel like we're doing something new, and um, this is the part that we've missed in math class the most is the you get to ask the question and then I have to clarify my explanation. So before we do that, here are a couple of people's energy levels. Looks like a heartbeat. The graph isn't necessarily a very accurate representation. I'm trying to show that my energy level changes. It depends on the time of the day. During Zoom, it's low to neutral. Then when I go to practice, I get oddly hyper. Then it goes back down to neutral until later around 10, it goes back up. I thought it was a cool looking graph and a good explanation. Next one, my energy level spikes up and down between the days. We can definitely all relate to that. I've had a pretty high energy the past couple of weeks, probably because of the 3 weekends we've had this week. However, I've been pretty drained. What's nice about this is we're talking about graphs and rates of change. Obviously, these things are not quantifiable. However, the slope does matter. Not only which direction, but how steep does matter. Okay, so on to the questions. Delta in math, delta is used, a triangle is used to represent delta, and it means the change in. A lot of times you'll see that triangle on fraternities. It's the Greek letter for D, but in math and in science classes, that triangle delta is always going to be change in. So delta y over delta x, or triangle y over triangle x, is a measure of the slope because it's the change in y over the change in x. Conceptual questions. These I thought were all somewhat related. Confused on IROC. How does it differ from average rate of change? Instead of finding the rate of change between 2 points or on a curve on a tangent line, is there a way to show the rate at which the change is changing infinitely many times between 2 points on a curve? Why do you need to find the tangent line as it approaches zero? What is this concept used for? How does the limit affect the equation in the IROC equation? These are all kind of like big picture questions. Like it takes a little bit of time for this concept to settle home. But what I tried to do was create a, a, a an example where you can see I've created on Desmos. So you don't have to worry about how I did it so much, but this is something that's calculating the average rate of change between 2 points. And I can make it between 2 points that are far away, or I can make it points that are close together. So let's just say I have a point. The point is 1. And I want to know, by the way, what's the line that's tangent to the function at that point? Well, let's take a second and go to, there was a question. I remember learning about tangent lines in geometry as relating to circles, being perpendicular with the circle's radius. How do I get a tangent line from a curve that is not a circle? Well, what I always say is like you can think of a tangent like as sometimes your teachers are normally talking at you and they're going around and around in circles, and then but then sometimes they're going around and around in circles, and then at some point they go off on a tangent. Okay, the tangent of a circle is a line that hits that circle at only 1 point. Remember, a chord I think goes through it at 2 points. A tangent hits it at 1 point. And you typically learn of this concept as it relates to circles in geometry. However, a tangent can be a line that hits any curve at 1 point. Okay, so this is the same tangent. It's just in a slightly different context. How is IROC important? Like, what's the practical benefit of knowing it? Well, it is important. What I am looking for in this particular thing is the instantaneous rate of change. Like, let's say it's that person that's rounding the bases, but their speed is changing the entire time. So this is something that's nonlinear. Anything that's curved is nonlinear, and it's if something is linear, its rate of change is constant. If something is nonlinear, its rate of change is changing. And I want to know at that exact moment of time, like let's say when if his foot is on second base, it only happens for an instant, like an infinitely small sliver of time. And I want to know exactly what his speed is. That's what this thing is for. Okay. And so what I would do to find what that speed is when his foot's on first base, that's the point x is equal to 1. I could take an average and I could say, well, let's take the average when I go from 1 to I don't know, 3. Okay, if I zoom out, this is going to be between x is equal to 1 and x is equal to 3. Is that a good approximation? Maybe. Could I do better? Probably. How would I do better? I'd pick a number that's a little bit closer. So let's go from x is equal to 1 to x is equal to 2. Is that better? Yep, it's better. Could I do better? Yep, you can always do better. How low can you go? It's like the game of limbo. Low and slow, that is the tempo. But in my particular example, I'm not going to get any smaller than 0.1 because I don't want your minds to explode yet. But the concept is, as I get closer and closer to 0, this line becomes the instantaneous rate of change instead of the average rate of change. And that is a line that is tangent to the graph at that one point. How do you compare the slopes of two lines? Are there various ways? How do we tackle variable slopes? Still not too sure about the instant rate of change aspect versus the average rate of change makes sense. Can we calculate the rate for a function with different slopes? You can, and it would be the same way. I mean, this function has a different, if I change the a value to right here, notice that at a is equal to 2, that line's steeper. So that has different slopes at different points in the graph. I think you're thinking of if it was a piecewise function and there were like two different pieces. Yes, you could do this with the piecewise function. You won't see it very often, but you still could do it. Does IROC describe a single point or the whole section of the graph from x plus h to x? Is IROC a specific point or the section between 2 points as it approaches the limit? That's a good question. IROC is really a concept, and the concept that it's trying to show you is as you get infinitely, I mean, I'm just restating what I already stated before, but I think it bears repeating, that I'm getting smaller and 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 smaller, and I get infinitely close to 0. All right, if I said I wasn't going to do this, but now I'll go with 0.001, and I can make the steps 0.01, and I could make this 0.2, and then I could, let's see how close I can get. I'm getting closer and closer and closer, and I could do that again, and I could still get closer. The concept of IROC is the limit of that as I get to 0.